Welcome to another physics video. Today our topic is motion graphs. Our goal is to be able to take a description of motion, in words, and produce a complete set of motion graphs. In order to do this, we'll need to keep a few basic concepts in mind. The biggest thing to remember is that you need to make sure you know what kind of graph you want to make, before you can start thinking about slope or whether the graph should rise or fall. Let's take a look at some basic graphs to remind ourselves about how we interpret them. We'll start with the velocity versus time graph. As you can see, there are 6 different parts to this graph. We'll look at each part separately first. Remember that when you look at a velocity graph, the direction of motion is not determined by the shape of the graph, but whether the velocity is positive or negative. Section A shows an object with constant, positive, velocity. So we know this object is moving forward and it is not accelerating. It is moving forward because the velocity is positive. It is not accelerating because the velocity is constant. Now, let's look at section B. Here we have constant, negative, velocity. What does this tell you about the motion? Negative velocity means the object is moving backwards and constant velocity means there is no acceleration. Moving on to the next section, what do you think is happening here? Section C, shown in red, is an object that is moving forward. This is because the velocity values are positive. Remember, the shape of this graph does not tell you the direction. In this section, because the graph has a slope, we know the object is accelerating. Is it gaining speed or losing speed? We can answer this question by looking at the velocity values. As time moves forward, the speed is getting closer to zero, so this object is slowing down. So, section C shows an object moving forward, but losing speed. The slope tells us that the acceleration for this section is negative. Section D, like section C, has negative slope, so we know the acceleration is negative here. In which direction is the object moving? Well, the velocity values are negative, so that tells us the object is moving backwards. And, the values are getting farther away from zero. So, in section D, the object is moving backwards, with negative acceleration, and it is gaining speed. Section E, shown in green, still has negative velocity values, so the object is still moving backwards. Once again, it is not the shape of this graph that tells us the direction. However, this section has positive slope, so the object has positive acceleration. To see the effect of the acceleration, we look at the velocity values and see that the speed is getting closer to zero, so here, the object is slowing down. So, section D shows an object moving backwards and slowing down. Finally, we arrive at section F. Here we have positive velocity values with positive slope. What does this tell you about the motion? Positive velocity means the object is moving forward. Positive slope means the acceleration is positive. The values are moving away from zero, so this object is gaining speed. Now, let's look to see if we can spot any trends from this information. Take a look at section C and section E. In both C and E the object is slowing down. in both C and E the velocity and acceleration are in opposite directions. So, we can conclude that, whenever the velocity and acceleration are in opposite directions, the object will slow down. Now, let's look at sections D and F. In both cases the velocity and acceleration are in the same direction. And, in both cases the object is gaining speed. So, if you want to go faster, accelerate in the same direction as the motion. But, if you want to slow down, accelerate in the opposite direction of the motion. Remember, the key to interpreting this graph is that any sort of line in the yellow section represents positive, or forward motion. On the other hand, any sort of line in the orange section represents negative, or backwards, motion. Now, let's see if we can create a position graph to match this velocity graph. We'll add to the position graph, one section at a time, until we have all 6 sections. Recall that section A shows constant positive motion. On the position graph, positive motion means go up, and constant motion means a straight line. So, that is what we have drawn. I've added the position graph for section B. Here we had negative motion, so this graph moves downward. Since the motion was constant, we have a straight line here. Before we draw section C, let's think about what it might look like. The velocity graph tells us to move forward and accelerate, so we know we need a graph that goes up here. And, it has to curve. But, we need to slow down. On the position graph this means have less slope. So, we want an upward curve that loses slope. Here is what it looks like. Notice that at the beginning of section C the slope is steep. This means high speed. But, near the end, the slope is smaller, so we have lost speed. What do you think will happen for section D? Will the position graph go up, or down? Will it be straight, or a curve? Here is section D. Negative velocity means that the graph goes down. Gaining speed means the graph must curve, and get steeper as time goes by. This is just what happens. Notice that both section C and D have negative acceleration. And, both curves face downward. We'll have to see if this is a hint about the direction of acceleration. Now, take a look at section E. I ran out of room on my position graph, but this section should also move downward because the velocity is negative. And, the graph has to lose slope because the object is slowing down. Verify that this curve does exactly what I described. It starts out steep and flattens out as time goes by, while moving down. Now, let's add the last section. Section F shows an object moving forward, and gaining speed. This is exactly what the velocity graph described. The slope is increasing, and, this is how we know it's gaining speed. One last feature to explore is the way the curves face. Remember, in section C and D, the curve faces down, towards the negative direction. And the acceleration was negative. On the other hand, in sections E and F, the curve faces upwards, in the positive direction, and the acceleration was positive. So, it appears that the way the curve faces, up or down, will tell us if we have positive or negative acceleration. That's all of the information for this video. Good luck drawing motion graphs.